So Legos, we talked about Legos before. This is another one of our Legos, and it works like Legos as well. We have low mass engineered check valves. First off, you might ask, why are you engineering a check valve? It's a ball on a spring. Yes, it's a ball on a spring. At least that's the schematic, right? If you talk about or kind of dive into that ball on the spring, you have a sphere, and the benefit of that sphere is that it's going to seal in any direction on the seat, and that's great. The disadvantage of that ball is you have all of that mass on that ball, and it's always there. And when it opens, you get a spike, and everybody gets a first order spike when you're opening your check valve. The thing with the ball is it comes back really quickly with the spring behind it and all of that inertia, and it bounces off the seat and it gives you a second order spike. And then of course it'll settle down, making a lot of noise as it does it, but it'll settle down. That's the other thing about a ball check. We all for 25 years I've been in hydraulics, ball checks equal noise. We always have the noise on the check valves. And the reason, like I said, it's a bouncing check, whether it's a ball on a hardened seat or a poppet on a hardened seat, they're going to bounce because that's what they do. We saw that as a problem that needed a solution, and we came up with what we call our low mass check valves. We have two different designs. One's called a disc style and one's a poppet style. That low mass means to you less system instability. You're not going to hear noise. It's going to be less heat, way less pressure drop, and again, less noise. Our check valves come, whether it's disc or poppet, in many standard fittings and connection options, both high and low pressure, and virtually leak free. I'm going to go to our spec page. Again, our spec page looks very similar to everybody else's. It's operating pressure 6,000 psi. We are max flow is size dependent. And our cracking pressures, it's kind of funny. We don't really have any standard cracking pressures, but we have standard cracking pressures. So if you want 1, 5, 15, 43, 65, or any other cracking pressure up to about 12 bar or 170 PSI, ask. We have most likely already done it or have a valve in production that has it. Very, very flexible design. Again, Legos, just put a different spring in, put a different poppet in, put it in a different configuration, and we can get something that is a solution for you. Disc check, where would you want to use a disc check? Well, if I go back to the previous slide, you saw this disc check is actually being inserted into an ORF style fitting. That's exactly what it can do. You can buy the insertable version of the disc check, use it as a service item. You have two valves that are talking to each other on a piece of equipment, and you need to put a check valve in between. Instead of cutting a hose and finding a place to put a manifold or an inline check, you can just crack a hose, put an insert in there, and before you know it, everything's quieted down because you have a nice check valve in between. Our leakage, as I said before, it's 1 cc at 2,500 psi. We have several mounting examples. These are just a few mounting examples of what we have done in the past. And you can see here, this is just standard inline. This is our poppet style. You can see why we have less mass. A, we use aluminum, and B, we cut out all that mass from the inside. Yes, this is a 6,000 psi check. This is a close-up of our insert check, and this is just an example of one of the manifolds that we've designed with our poppet check inside. What's exciting is we have a cartridge design coming soon. So all the benefits of our poppet is going to be in a -10 cartridge very soon. And when I mean very soon, hopefully we're targeting the summer that we'll be able to offer this to the market. It's going to have a max operating pressure of 6,000 psi. It's going to be in -10 first, and we're working on the -8 right behind it. So cavities, we're going to stick with the standard dash first, and then we'll get into the specialty cavities. Max flow on this -10 is 20 gallons a minute at 150 psi. Standard, this one we are going to stick with standard cracking pressures for the immediate, and then go to customs later. So we're going to offer it at 5, 15, 43, 60, 65, and 90. Leakage is going to be the same as our standard Poppet style, 1 cc at 2500 psi. And the nice thing, and what sets this one apart, is the porting is 1 to 2, or nose to side, or side to nose. So the side to nose is going to look almost exactly, well, it's going to look exactly like the nose to side. Nice thing about our design is you can just flip that Poppet around on the inside and you have a different cartridge. With that, I will ask if there are any questions.
Somebody wanted you to go over why choosing a Poppet over a disc check.
Great question. We only have 2 sizes of disc check, so you're going to either get a 16 or a 12. So disc check and Poppet from a pressure drop situation or a high pressure or low pressure situation is very similar. We have a patent on that disc check, so we can pretty much do whatever we want with it. The Poppet check is quieter. I will say that it's quieter and it's more damped. It has a little bit better pressure drop than the disc check, and sometimes it's more flexible. That Poppet can be flipped around in multiple directions, and the cavity is very, very simple if we want to design a manifold with it. The difference is one's steel and one's aluminum. However, they both can do high pressure. Hopefully that answered the question.
Yeah, I believe so. Let's see. So this is actually an interesting one. You currently have a stocking program for joysticks. Are you looking to create a stocking program for check valves?
That's been brought up several times. It's just a matter of figuring out what the market really needs in the sizes that they need. Matt, I believe you are working on that. And
Yes, sir.
I don't know if we have any time frame that we're looking at a stocking program for check valves.
Well, currently we're looking at doing a little bit more of data mining just to make sure that we're putting the right products out there
Okay.
that the customers may need.
Any other questions, Eric?
Let's see. One more. What is the largest disc check that you can make?
Right now, we're working on a -32 size, and we could make them bigger. It's just a matter of design FEA, doing some engineering around it and seeing what kind of flows and pressures it needs to hold up to. So right now 32, but sky's the limit for the disc checks. And really the benefit of the disc check is it's really not limited in size.